Welcome back. In this section, we are going to talk about MIMO in LTE Advanced. MIMO is stands for multiple input, multiple output. MIMO is a key part of LTE deployments. LTE standard is based on the combination of MIMO multi-antenna techniques and OFDM multi-carrier techniques. And one of the main reasons why OFDMA was actually adopted for LTE was its ease of support and ease of implementing MIMO using OFDM, because you get into these subcarriers these subcarriers can be multiplexed along different transmission paths easily. So here we have the transmitter and the receiver. We have signals coming in from the into the transmitter. We have, in this case, four antennas at the transmitter and four antennas at the receiver. Now, at every receiver, due to the multipath, we will receive will receive signals from each of the four transmitting elements. So the relationship between the received and transmitted signals on different antenna paths is expressed as a system of linear equations. In this system, the vector of received signals is expressed as a product of the channel matrix and the transmitted signal. The transmission matrix H contains the channel impulse response H n comma m, where n represents the transmit antenna, m represents the receive antenna. Um, the rank of the transmission matrix H defines the number of independent data streams that can be transmitted continuously. So y is equal to hx, and where h is the channel information matrix. This information matrix is derived based on the feedback um, um, that the UE um, either gives to the E node B, or it is also derived in the downlink direction by using the cell specific reference signals that the user is able to decode. MIMO in LTE has been around for quite some time now. So we have transmit diversity, where we increase the robustness of data transmission. In this case, the same data is transmitted redundantly over more than one transmit antenna. This increases the signal to noise ratio at the receiver, and space-time coding is used to generate the redundant signals. This is actually the simplest form of MIMO technique, which is used in LTE, where, say, for cell edge users or users that are experiencing a very low SINR and thus reporting a low CQI. Spatial multiplexing. This is used to increase the data rate. In this case, the data is divided into separate streams, which are then transmitted simultaneously over the same air interface and resources. The transmission includes special signals called reference signals, which are known to the receiver, and this helps the RX in channel estimation. Spatial multiplexing can either be closed loop or open loop. So, spatial multiplexing is where we truly start seeing MIMO, where we are able to divide the data stream and send these data streams over different transmission paths, and we actually have two transmit modes in LTE, TM3 and TM4. Um, TM3 is the open loop and TM4 is the closed loop. The difference between TM3 and TM4 is TM4 we use pre-coding, which is sort of like a crude form of beamforming you can think of, which even gets better results as compared to TM3. Further, spatial multiplexing can either be single user or multi-user. In a single user scenario, the data rate is increased for a single UE. When individual streams are assigned to multiple UEs at the same time, it is called multi-user MIMO. So if you look at this picture here, this is an example of the single user MIMO in LTE, where we have the base station on one side, we have the UE on the other side. We have a 2 by 2 system, and in this case, we are sending the data streams Y2, transmit signals and receiving Y2, and every received signal is a combination of signals from 1 and 2. And the channel impulse response is estimated by the UE based on the cell specific reference signals, and then the demodulation happens, and that's how we uh, get a higher data rate for this single user. Evolving this to the multi-user MIMO case, where we still have two transmitters at the base station, but here we have one receiver at each of the UEs. Here the UE receives signals from both antennas. However, the data rate here is not as high as a single user MIMO, because in the single user MIMO you were receiving essentially two dedicated streams. But multi-user MIMO is essential for increasing your system capacity. It may not give you the best peak throughput performance. Multi-user MIMO is again a key part of LTE Advanced, and now there is support for 8 by 8 MIMO as well in LTE Advanced. So this wraps up our discussion on MIMO, multi-user and single-user MIMO. Hopefully now you have a decent understanding of the MIMO technologies in LTE Advanced.